All right, perfect. So one of the things that I added was a project risk template because I realized that some individuals were really not familiar with understanding how to quantify the risk or capture the risk. And so this template, and let me go ahead and share that. I'm going to share the template with you. And so what this template does, it does a great job of capturing all those items. And so right here, you have risk status. Usually the risk is either open or closed. And so right here, you see that the risk is open. You just click on this little macro here. You can change it to close. And then you see that the risk map itself becomes closed. But since you have the risk is open, you say it's open. You say that your risk impact, maybe the risk impact is medium. And you'll notice that this risk map changes as well. The probability of occurrence, you have 3.
Okay.
You have low, medium, high. But like what I said the other day, in reality, if you have a risk that is 85% or higher, essentially that particular risk is no longer a risk, it's a reality. It's going to happen. So you have to look at your project schedule and say, okay, it's going to happen. What are the impacts to my schedule? You know, do I need more staffing? You know, what is going to actually happen and change my schedule? And so this risk map here, you don't change. You only change these 2 items, and it either goes green, yellow, or red. And so it kind of gives you an idea, like, you know, how serious this is.
Mm-hmm.
And so here they have an example, but we can just put any example here. We say that we have a medium risk, probability is high, and so now you see it's red, and the risk description is lack of education for users to use use data or something like that.
Mm-hmm.
That could be kind of a risk description. The impact is confidential information being leaked. Then you have risk areas, and so the risk areas, these are all the various items that the risk can be associated with. So here there's a few items already there, and so this one is dealing with authentication. So you just click security. So you have security as one, and then of course I'm using LibreOffice, but if you're using like Microsoft Excel, you can click these other items, no problem. But here it's just that I can only click one item just because I'm using Libre. So here I will, it's security. So I say security, and then I put the symptoms in there, and then I put triggers. And so if you look at the one previous, it says schedule approaches and required start date with no identification, required skill sets. The triggers is 4 weeks prior to schedule start date, if no resources identified, with required skill set, implement contingency plan. So the trigger is, you know, what do you do? So you get to that point where you say in your schedule, you say, okay, well, we know we need this particular item done, right? We need this particular item designed, and person X hasn't designed it yet, and it's 3 weeks before the project is due. Hopefully, it's way before then. You say, all right, we need to immediately put someone else on this task, or the person needs help. You know, maybe they're behind, maybe their schedule is really behind, and maybe the trigger is you ask for me to write, I don't know, a letter to your boss to say that, hey, you can't really work this weekend. You have some type of critical task, or we see that we can get you some additional help, or that I help out as well. I say, okay, well, I can help you fix X, Y, and Z, or we come to we have a meeting or come to a consensus that we have to de-scope what you've done. Maybe what you've come up with for your project is way too much and too aggressive for the time that we have allotted for this course.
Right.
And then here you have your risk response strategy. So this is a mitigation, but you have others. And so in terms of risk management, you have risk acceptance, and this is when you just accept the risk.
Okay.
I'm going to make this a little bit bigger.
Sorry.
No problem. I see you. See your eyes. All right. So what you should see is you have risk acceptance. And so this is just essentially when you accept the risk. You say, all right, I'm going to accept this particular risk because it's easier to accept the risk, and then maybe the impact is very low. Okay. And then you have avoidance. So essentially you're just going to avoid the risk completely. Maybe avoiding the risk is switching operating systems or switching IDEs. For example, after we do the midterm, we're going to learn about some GUI design, and we're going to be using PyQt. And so maybe the tool or IDE that you're using doesn't allow you to do what you need to do. So you're like, okay, well, we need to design some type of interface. Well, the interface may need to be done with PyQt. However, maybe you're doing something that's web-based. You're like, no, we can add some HTML in here. It may be easier. So you're going to avoid the item completely by using another technology or different personnel or even different location for the organization. So that would be avoidance. Then you have contingency. So contingency is basically you have like a plan A, a plan B, a plan C.
Mhm.
Maybe there's a risk that you're going to move your organizational staff to, well, you're going to place them in New Orleans. And so now you have Hurricane Katrina, you have severe storms down there. Now you have to say, okay, my contingency is that if something happens to this particular location, we can move them north 100 miles to this other location, which is maybe a warm, hot, or cold site for a contingency spot. And those sites, warm, hot, or cold, that just basically deals with the amount of time it takes to actually get that facility operational. And so you just say, I'm going to move into X facility if something were to occur. So that would be contingency. And of course, here you have mitigation. So there's another risk response strategy. It's you know, how are you going to mitigate it? Maybe mitigating is adding more people to the actual task, which happens a lot, especially in software design tasks. If you're behind schedule, they say, okay, well, you're behind schedule, you know, 2-3 months. We're going to add 20 people to the task to do the work. That's how we're going to mitigate it. We're going to add more people or throw more money at it. And it depends on really maybe the past experience or past similar programs done within the organization, if that's even a real you know, risk response. Sometimes it's the worst because now you have more hands actually on the code, and maybe the organization is not able to handle so many software changes. They lack capability maturity model index, you know, CMMI level 3 or higher, and they're unable to handle so many changes like that in that particular environment. And then also maybe the people they're throwing at it do not have the expertise needed to actually get the task done, and that schedule just may have to shift out to the right, or they may have to de-scope what they've initially were trying to do.
Okay.
And then you have transfer. And so transfer is another kind of risk. So you're in a group, and maybe your group is responsible for designing the user interface for the actual application. And you realize that the risk is not really associated with you, so you transfer that risk to another group that risk is associated with. So maybe you're strictly focusing on UI stuff. You're like, okay, well, we're doing the UI stuff, but we don't really control where passwords are stored. So we're going to send it to the group that is actually in charge of actually where data is stored in a particular application. So that risk is no longer yours; it's transferred to another group. However, at the higher level, the program or project manager, they still have responsibility for all those risks, even the systems level person. So as a group, you say, okay, well, this risk is not us. This is someone else's risk, and it's transferred to the person who that risk is responsible for, and then that person has to address how that risk is taken care of.
Right.
And then here's just showing the response strategy. So here's just saying that, just showing an example, find internal resource that meets the required skill or set training on existing resources. So here's just what is the response, and then of course the associated contingency plan with that actual response.
Okay.
So this is the tool or the spreadsheet that you can use to actually document all of your risk and track those risks.
Okay.
So how are you doing documenting your risks thus far?
Yeah, we're pretty solid with that. It doesn't go into as much detail as your examples are, but we documented the amount of talent that we have, the time frame, the kind of testing that we'll have to do, things like that. So, and we have the risk impact and the probability on there. We just don't have the current status, and also the risk area we haven't outlined. So we're just missing a couple of those categories.
All right. Can I take a look at what you currently have?
That's saved on my UMSL drive.
Okay.
Yeah.
Your UMSL Google Drive or just your UMSL Drive in general?
Just the drive in general.
Ah.
The K drive or whatever the students get.
Okay.
I forgot to upload it.
No problem. Because one of the things here, if it's on a shared drive or something like that, you can just log in here. To the left, you should see a Google Drive symbol, and you can actually, share it just through that using a Google Drive.
Oh, cool. I'll have to remember to upload that next time I'm on campus.
Oh yeah, it's pretty good tool.
Cool.
All right, so that is that in terms of risk management. Let me pull
Okay.
up another item here. And then there's a document. It is called the NIST Special Pubs 800.37, and so it talks about it's the NIST 800 series is a series that talks about computer security. However, those risks are associated with pretty much any IT project when you think about security and things of particular nature. But this is the actual government standards for actually managing risk, and they talk about risks that happen at 3 different tiers. You have
Okay.
the organizational level. Let me drag this. Yeah, you have the organizational level. That's like your highest tier. So this is like governance. This is like COBIT, which is something that deals with ISACA. It deals with control objectives of business and information technology. How do you govern? You have governance for like risk management over an entire enterprise. Then
Okay.
you have tier 2, which is like mission and business processes. So this is your information flows. And then tier 3 is your environment of operations. So this is your strictly your information system. And so you at the top, your tier 1, it's more strategic, and then you get down to tactical risk. And so you look at the risk management from an entire tier approach. So
Okay.
that's something else to think about as well. When you're looking at your risk, think about the risk at a higher level, at your organizational level. So your project manager or your team lead should come up with risk as well. So what are the risks that she sees from an organizational standpoint? That deals with like staffing, holidays, inadequate time in the schedule, and then you guys can come up with tactical risk. What are the risks that if you're working a particular task and you know that you don't have the required skill sets to develop a particular application, or someone is not familiar with testing. Say, okay, well, we know that we do not have the required tool for testing. We don't have expertise for running the Microsoft threat analysis tool, right? Or we don't have any expertise for running any threat analysis tools in general. So that is identified as a risk, and then you think about how do you mitigate that risk. And so maybe the mitigation is we need to have an additional training to talk about that particular risk. Not risk, but that particular tool, and go through a training. Like what has happened in the past, we would order new software suites or applications. We're going to run a penetration test. However, no one has used this particular tool. So when we actually write that in our particular contract, we would also ask for training to minimize the amount of time it will take for an individual to get familiar with a particular tool suite. We say, hey, we need a week or 2 weeks to run this tool. And even operating systems. If you're an organization and your customer says, this $1 million product we cannot pay for any longer. However, if you can shed cost by almost half, we will continue with your product. So you say, okay, we can do that. However, the new operating system that we're going to deploy your stuff on, we have almost zero expertise. And we actually had that working where we switched everything from pretty much Windows to Red Hat. And so we had to take 3 weeks, almost 15 people to do Red Hat training, to get certified, the Red Hat certified system engineers and analysts and stuff like that, just because we had the expertise of Red Hat Enterprise Linux was next to none. It was spread amongst a few people. But our customer knew that in order for us to get a product out there at a reasonable cost, that we had to switch OSs and go to open source.
Right.
So something to think about as well. And so with your particular project, think about the tools that you're using. So right now you have different IDEs that you should be familiar with. IDLE, the regular Python IDLE. You have Ninja IDE. You have PyCharm. And so with those, think about what you can do, because they each have their own limitations. And you have to do anything that's GUI based, then you have to do PyQt. And then if you need to do an actual hardware application, or have an application to do something additional, then you may need something else, maybe like a Raspberry Pi device, like 30, 35, 40 bucks to do some additional capability. So think about your entire system. So you have your boundary. Remember we did our system boundary?
Right.
So you have your system boundary, and you have what you're responsible for, but you also have to think about all the other items that your system needs to actually connect and talk to. And so when you think about that, think about interoperability. So what is actually going to allow you to work with those systems, sending either messages back and forth or communicating, or working with the system so it can actually work. So So let's talk about your project real quick. So what are all the items that are identified that you guys need to do?
Um, you mean from like the high level?
The high level.
So the project requirements, we Ron's working on the coding itself because he's the one that
Okay.
is most comfortable with everything like that. Um, and then once we get that, we're going to test it, make sure that it's, functional testing
Mhm.
first, and then the user acceptance testing and penetration testing after that. Um,
All right. Let's
and
stop on penetration testing. What are you going to use to do penetration testing?
I'm not sure we haven't crossed that bridge yet.
All right. So that could be a potential risk. Does
Right.
anybody there do pen testing at all?
Yes, I'm pretty sure Tammy, since she is all about security, is pretty solid with some penetration testing.
Okay. But if she's not, because if you're doing pen testing, you should be running a item called Kali Linux.
Okay.
So Kali Linux is a full-fledged security suite that offers a lot of offensive items. You can run Nmap, Nessus, you have Wireshark, just a ton of different items that you can run, dictionary attacks, um, Bluetooth attacks, all types of different attacks you can run, and you can use that as your testing against terms of security and things of that particular nature,
Right.
and everything is built in.
Okay.
So that's something to think about. And then and also when you do pen testing, one of the things to consider is, are you going to provide some type of credential? So are you going to say, I want you to run all of these attacks against the system. I'm going to give you the items in a VM, or I'm going to give it to you as as black box. You know nothing about it. So what information do you provide in terms of your level of assurance when you pen test? So you have to think about that as well. Because
Right.
sometimes the pen testing is, hey, I'm going to give you my laptop, hack into it.
Right.
However, I may just say, here's my IP address, hack into that, or hey, I'm out there on the net some way. I'm out there on the net somehow. Try to find me, locate me using some type of BI related item. Find me on Facebook or some type of social media page, and find me that way, and then see what information you can pull from me, and then find my location. So
Right.
think about how much you're going to actually give when you do that particular pen test.
I think we were talking about putting a link to our website on Reddit and having it open source tested or crowd tested or something like that. So that was Ron's idea.
Okay, that's
Just
good.
letting users go at it.
Hopefully you put it in a sandbox and they don't tear up your real app.
Yeah, hopefully. We'll leave that up to Ron.
Yeah, but I will post the NIST special pubs. It is a great wealth of information in
Okay.
terms of monitoring risk. Like I said, even though a lot of it's strictly security focused, but it still covers IS, which is very general in nature.
Hmm.
It talks about ways of looking at your controls, implementing your controls, and all that stuff. And it will be great for your security portion. So in terms of risk management, did you have any other questions there or any other outstanding issues?
Not really, no.
Okay.
Hopefully they'll come up because they work on it
And,
more.
all right, and your other team member is doing the threat modeling, correct?
Right. That's Mamoon.
Uh, and Mamoon is not here.
No. I'm representing the team today.
Okay. Lucky you. What I'll do is I
Yeah.
will go through this. I shared this document um, in the course page.
Okay.
And so this presentation is pretty good. It is Introduction to Microsoft Security Development Lifecycle Threat Modeling.
Hmm.
And it uses the same tool that you guys can load on your Microsoft systems. And if you're using Linux, you can just either load it in a Windows VM, or you can run Wine or Play on Linux or one of those other tools that run Wine, so you can have a virtualized environment that makes it computer, or at least the application, feel it's Windows.
Okay.
So it's about 77 slides, but what it does, it provides, like, it talks about introduction and goals, how to threat model, approach to threat modeling, diagram validation rules of thumb, exercise that has a demo, but we'll just go through some high-level stuff.
Okay.
All right, so here's talking about terminology and context. Basically, here it's talking about what security experts say, and then you have requirement design, design analysis. And this is pretty cool because in terms of development stages, it's the same stuff that you guys are doing now because now you have your requirements. You'll go into design,
Hmm.
and then after you do your design, you'll have your design analysis. So essentially, you say, you know what your requirements are. You know what you must do for your actual system to be functional and to work. And so once you know those actual requirements, then you have to think about, okay, the security aspect of the particular items. Like you say you're going to put your item on Reddit, so maybe you find out that the login method is very weak. Maybe you're accepting weak passwords or you're not enforcing various roles that you need to enforce. And so this will help you understand kind of how that fits in terms of the context of threat modeling.
Okay.
All right, so various basics. You have the who. So the who are the bad guys, but the bad guys don't necessarily have to be external. They can be internal. So you can have a disgruntled employee, and employee's like, you know what, I hate this job. Sophie's a horrible boss. Hopefully you're a great boss in the future. But they're disgruntled, and they're like, okay, I'm going to do something. And so that could be one of the items to use in terms of modeling your threat, looking at internal threats that may arise. And then you have what, and so the what is basically just a repeatable process to find and address all threats in your product. And this is when we talked about CMMI in terms of actually software design and development, is that you have to have repeatable processes because if you change something, how will you know if you're actually doing it to a particular level or it will work in the future? So, for example, if you have a process for pen testing, right? When you create your process for pen testing, you document that. In the future, when you do this item again with the same product, how do you know if your product security is actually enhanced or weakened, especially if you have a completely different process? So that data that you captured the first time is null and void because you have a whole new process that may measure different aspects of your application and the security surrounding that.
Okay.
It's like with a university. Like we have this AACSB accreditation, so it's a great accreditation for the College of Business. However, if we were to say we're going to do something completely different off the rails in terms of measuring our own internal productivity, research, and stuff like that, we could essentially that data that we captured before is null and void because we're doing something different. So we have different metrics to actually look at. And so in terms of pen testing and understanding the threats to your organization and how you're going to test those threats, you have to have something that's repeatable. That's why we talked about sending software overseas, like to India and China, have it develop. Some of the issues are, the main item is a repeatable process. That is why these capability maturity models or maturity models are so important to engineering.
Mm-hmm.
All right, so here you have the when, and so basically it's just saying the earlier you start, the more time you plan and fix. Now, this is true not just for security, but also quality. So the longer you wait to fix something, you have to go further back into the design or development process to actually fix the, well, you have to go further back to actually implement that correction. So imagine if you're looking at, imagine you're at day 1 out of day 400, and you're like, okay, I know there's a risk. On day 1, you know there's a risk, but you wait until, day 40, and day 40 you actually fix it. Day 40 is better than day 300 because now day 300 you're like, okay, day 300 we're probably getting ready to almost ship off the product. We're in testing. We're doing what they call low fidelity prototypes, or we have low rate initial production. We have some type of pretty much, well, more than low fidelity. You probably actually are in a low rate production stage where you're actually putting out some version of the product out on the market. But now you know that you have these issues. Now you have to go all the way back to maybe day 100 to fix these items, essentially. So you have to move your schedule all the way back, and all that money that you spent has to get respent for additional testing, because now you have this other fix that you brought into the actual product. Now you have to test and make sure that fix actually works. So it gets really expensive. It's like building a house, and you're like, okay, the pipes are incorrectly, and the house is built. Now you have to tear down all the stuff at the house, fix the pipes, and the same thing happens in software. Because when you're actually meeting customer deadlines and you have various, especially a certification like ISO and CMMI and all this other stuff, and you're getting ready to put that stamp of approval, you have to go back and go through all those other checks. And if you do work with a state or federal government, especially federal government, like the Department of Defense or the Army or something like that, they have tons of various checks that you have to go through, and they require various certificates of testing or acceptance and stuff. And so now you find out you have this item in there, it never got fixed. Now you have to go back and redo all these items, and you may have to test all the stuff you've already paid for to test once, test it again.
Mm-hmm.
And so the same thing happens to quality. So if you know that you have poor quality in your software up front, then you should fix it up front. Do not wait to the last minute to fix something that is bad. Address that item, as fast as you can. And that's why risk management is important as well. So when you do your threat modeling, you may find out that you have other associated risks. You may say, oh, okay, well, we have this technical risk that we didn't think about before, so we need to go ahead and try to address that now. You get that item captured as a risk, and you go ahead and start tracking those risks immediately. Like that risk spreadsheet, what is also good to do with the risk spreadsheet is actually to use a risk tracking system.
Mm-hmm.
So you identify a threat, and you have a new risk now, and you start tracking it in the risk tracking system, and then it actually should send out an email to the person who's responsible for handling that risk. If it's a high-level risk, they get an email every day. Doesn't matter. It's a Saturday, they're still getting an email. So it's always on their mind, and there's always some type of meeting or stand-up meeting to say, hey, how are you doing with the risk? What resource do you need to actually fix this particular risk? And then you have why.
Oh.
Okay, I'm back. Blame the UMSL internet. I was talking. I was like, wait a minute. It says the internet connection is lost. All right, let me reshare my document. All right, perfect. Okay, and then you have why. So why is basically finding problems when there's no time to fix them, and then security development requirement and deliver more secure products. And so this is why you want to do these items. So you want to. So if you find items up front,
Right.
you have more time to fix it. If you find them at the last bit, now you have to go all the way back and see what else is affected. Because sometimes when you add in a security, mechanism, like you can add more items for messaging and stuff like that. So now your messaging, maybe you have a requirement for messaging that says you must do it in X milliseconds. Well, now you can't because you have all these other items is encrypted. So now the time it takes to go from one system to another, it increases. So you can't meet that requirement anymore. And so now you got to say, okay, well, what else? What can I shed off to meet that requirement? What items aren't as important? And then a lot of times now, in terms of laws, you have to show due diligence and you have to show due diligence by showing you do care. So you're going to create a banking app. Well, you have to make sure that banking app is secure because you could be sued later. And you could be sued because they could say, well, you didn't show that you did your due diligence because you didn't show you cared. Because you would have done HTTPS, you would have maybe had AES encryption, you would have removed data from being stored in clear, things of that particular nature. So it also helps you as an organization not end up in jail or something. And then you have the how. So how are you going to do all these particular items? Any questions on this particular slide?
No.
All right, so here you have who. Basically, here it's just saying that you're going to build a threat model. The PM owns the overall process. The program manager or project manager owns the overall program or project. However, that individual is not actually the individual who's going to be running the actual tool and stuff like that. So basically, you have testers. Testers identify threats in the analysis phase. They use threat models to drive test plans. And this depends as well because if you have a security group, in that particular security engineer group, it will be a security person that will run these particular models and stuff. So you will actually have a cybersecurity analyst, cybersecurity engineer. They will run these particular threat models to see what threats are associated with the actual system. And so that is what they will do. And then it talks about customers for the threat models. You have multiple customers. You have internal, external customers as always. So of course you have your team, you have your end customer, and then you have stakeholders as well. And then here it says you need to decide what fits in your organization. Your organization may not be able to do an as extensive threat model, right? And depending upon your budget, you yourself may be limited to what you can actually do.
Okay.
Right? So this is one of those things, these program management things, scope, schedule, and then cost. So those three pillars go into every discipline, including software engineering. You want to build the greatest gee whiz gadget ever. Well, to do that is going to cost a couple $1 million. You only have $500,000, so you have to de-scope.
Excuse me.
Bless you.
Thanks.
All right. So here you have what, and so basically, all this here is saying basically document and discuss security in a structured way. And so the threat model and document talks about the product as a whole. But you don't just have to talk about the product, you can talk about the system. So you have your systems level threats, you have your product level threats as well. So you have your high level threats and then your product level threats. And then you have other items that maybe are associated with maybe where that item physically resides. And then here just saying it provides assurance that the modeling has been done well. And so when individuals review, like when you have your use cases and test cases, you and your team should actually review those together. So that's what generally happens. You say, okay, I got my test case, my use case, and we're going to review these items together to make sure that everything is covered and that we're looking at the entire picture and there's nothing being missed.
Okay.
All right, so why? Basically, you want to produce software that is secured. You want to have secured software. You don't want to have a product that is unsecured because it will damage your brand and reputation.
Right.
Right, so imagine a new iPhone 6 or iPhone 20 not only just bends in your hand, but also anyone can actually use it. That would destroy the brand of Apple. So you think about all the different attacks and all the cyber attacks, and what happens. You always have individuals on the press saying that we did our best, we try to do this, and they're trying to make sure that their brand is safe. Because when you have an attack on a particular product and it's a general consumer product, people will lose their trust in using it. It's like, well, I don't want to really buy this product because I like banking. I like doing e-banking. I don't want to buy this product because I can't afford to have someone, literally take all the money out of my account just by using a particular product. They'll switch to a different product. And then here is saying attackers think differently. So attackers are looking for exploits, right? So if you're an attacker, you're like, okay, well, I'm going to look at this particular product because I know they have weak designs. They have weak designs. It's going to be easier for me to attack this particular product. When you think about viruses, right? Most of the viruses, computer viruses, are made for what operating system?
Windows.
Yep. And why do you think Windows?
It's probably the most widely used, even by amateurs. They don't really know what they're doing.
Agreed. So Windows has more widespread use. You also have a lot more people who are not computer savvy, but they can use a Windows machine.
Right.
Then you have Mac, and so Mac is built off Unix, so it's a little bit more secure, but there's not as many users as there are for Windows. And then for Linux, why spend months writing a virus for X amount of users? It doesn't make any sense.
Right.
And you know that there's more flaws in Windows, than Linux. So it's like, okay, well, we know that these flaws exist, and then also the type of user associated with that system.
Mm-hmm.
All right, so we're going to jump to this section. All right, so here's talking about how to threat model. See if I can make it a little bit bigger. And here's just showing an example of a threat model that was done, that they've actually done, that was already captured in the presentation. And so you can see how they look at everything and what ties into what. You see that?
Right.
Yeah, so when you create your threat model, you can create a higher level view, and then you can break out your various subsystems or CSCIs out. So you know, you have here local user, you have Explorer, you have Castle services, shared account, see get account information, and so you can actually, you don't have to have as big, but what you can do if you want, you can just break it out in subsections, and so you can
Mhm.
just talk about that particular threat when you do yours.
Okay.
Yeah, so here is pretty cool. So talking about different threats affect each type of element. And so here it's talking about you have external entity, process, data store, data flow. And so you have different threat elements that really do affect your actual system when you're doing threat modeling. So you need to look at all those different elements that can actually affect your system. All right. So here it's talking about just a process. Basically, identify your threats, mitigate, validate, and diagram. So you have this just process of basically doing your threat modeling. And so when we talked about, you know, you're going to diagram these items out. So you're also, when you do your threat model, maybe you may have an additional requirement that comes up as well to actually make sure that this is secure, and you can do that in multiple ways. Who's actually testing your requirements? Who in your group is doing that?
Um, I think it's CC.
Okay. So we'll have another session. We'll go through actually pulling requirements in, and then, you know, 4 or 5 ways to actually test them, whether it's like inspection, analysis, or something like that.
Okay.
Now, do you have any of your actual threat modeling done? Anything done at this particular point?
No, that's my moon was working on that yesterday. I don't know if we got too far.
Okay. All right. So I guess this will be for definitely for Mamoon then. All right. So all this here talks about is basically how to create diagrams. Um, it's fairly simple. Here they just state go to the whiteboard, but you can use anything. If you guys are all using a Google Drive, so you can share all that information on Google Drive.
Mhm.
I think there's even a Google Whiteboard on Google Drive as well. Yep, there it is. And so you can write on Google Drive. But basically, what you want to do is understand the processes, how data is stored, data flows, and that's really what you do, and make sure it matches, you know, as much as to the real system as it should when you actually check the work.
Mhm.
Then you have diagrams. These are DFDs, data flow diagrams, and you can use this using some of the tools you have. You have Visio, you have the DA diagram draw. Which one are you guys using?
We were using Visio.
Okay. So when you have your DFDs and stuff, and you're looking at your boundaries and the way that data is going to flow within the system, that's all this is. This is all the same type of diagramming. And so generally what you have is you have that large systems level diagram, and then you break out that diagram and you just dive a little further and understand, you know, what application is talking to what application. And here it says update diagrams as products changes. That's with any change. So with CMMI, anytime you have a change, you have a system for approving that change. It's maintaining quality throughout the software design.
Mhm.
And so you say, okay, well, we're going to not talk to this other app anymore. We're going to talk to this other application. Thus, your diagrams need to reflect that update immediately, because the actual designers are designing to those diagrams that are already out there.
Right.
So here, just showing some various examples in terms of diagramming elements. External entity, this is people, other systems, processes. These are the different services right here. Data flow, network traffic, procedural calls, data stores, how data is being stored, memory, database, a file, it's being thrown in a QR stack, and then of course you have a trust boundary. And so this is basically the boundary either for the file, the process, and you also have the trust boundary for the system.
Mhm.
And so here, the only boundary that you guys have pretty much drawn so far is the boundary that you're responsible for in terms of the actual system.
Right.
So you could also potentially use that as your trust boundary as well. But if you're doing something that is app critical, then you got to decide and say, okay, this is our system boundary, but we need to make sure that this other item that is interfacing with us is safe as well. So maybe your boundary changes just a little bit.
Okay.
So system boundary and trust boundary can change. All right, so you have diagram iteration. So basically, it is iterative over processes, data stores, and then see why they need to be broken down. Then it also talks about how to know it needs to be broken down. This is easy, you just need more detail, because sometimes at the higher level you cannot see exactly what's going on at the CI or CSCI level, or the subsystem level. You say, okay, well I need to look at component level. What is going on at component level? Need another diagram to show that. All right, so here it just shows a context diagram. That's all this is. And here it shows a level 1 diagram. So you can see level 1, where you see the raw file system data, talking to the integrity host software, sending resource integrity data here, and then of course you have these boundaries drawn right here.
Right.
You can see all the different items that is occurring in this particular function. Now you have diagram layers. Same thing when you talk about risk and stuff like that. In risk, you have different types of risk and different levels of risk, from strategic to tactical.
Mm-hmm.
And diagram layers that they're showing here is you have the context diagram that's very high. That's product system level, very similar to your systems diagram.
Okay.
Level 1 diagram is basically a single scenario. Level 2, you're talking about subcomponents, and then level 3 is very, very detailed. I mean, this is your very low level.
Okay.
And these diagrams are for different audiences, right? So if you're talking to the program manager or the chief architect, they may want to see a level 1. You're talking about maybe the group lead, they may want to see a level 2, and then the actual people responsible for breaking down that actual system even further, they may need to design off a level 3 diagram, because they're only carrying, their whole world resolves around that little small component.
Mm-hmm.
All right, so here it just talks about analysis or synthesis. So you have two different approaches when you do anything. It's like management. You have your top-down approach, where you go from the high level to the low level. Then you have the bottom-up, which comes from the actual individuals themselves setting everything up. So they're saying that the bottom-up is more work. Top-down, you have the high-level view, and then from there you just continue to break it down. I've seen the bottom-up view be used, but like it says, it is more work overall, because now you have to make sure that bottoms-up view fits into the larger view. But it's easier to say, all right, this is what the system is, and now we're going to say you're going to break this small component down. You're going to just further break them down rather than try to build them up and make sure that they're actually able to integrate.
Okay.
All right, so here's just talking about diagram validation rules of thumbs. Okay, so here's showing web server, transaction to the web server, analytics, data syncs, right to store for a reason. Someone uses it. Make sure. Okay. Thought I was missing something. All right, so these are just talking about actually just diagram rules is pretty much all it's talking about. Just saying, does the data magically appear? Data comes from external entities. So what are the external entities? So here just showing that the external entity here is you have customer. Customer goes to the web server, and then from this web server it goes to the SQL database. And so they're basically saying that when you're doing these diagrams, you need to make sure that you have the external entities or data stores being displayed into the actual system. So this may be your system right here, all you're responsible for, this particular piece, web server and SQL database or any other systems to the right. However, where does the information come from, right? So where is the incoming and outgoing traffic, All right, I am going to talk to IT. All right, but again, all it's saying is that you need to understand all data traffic, and because if you're going to try to draw, or diagram or map out your security threats, you have to know all your points of entry, and so that's all that particular item is showing.
Right.
So let me jump back. All All right, so here just saying, are there any data sinks? Basically, you write to store for a reason, someone uses it. So here just showing that, so you saw that the items went to the SQL server, and we were talking about the stuff to the right.
Okay.
Now you see that the SQL server database, the information is there, and analytics, so you have individuals using it for analytics. So now you know that there is yet another piece.
Mm-hmm.
And then here just showing that data doesn't flow magically. Basically, you need to show how does the actual data flow through the entire system.
Okay.
So here you just see an order database, return database, the orders received returns, and then it sends information back to the return database. And then it talks about it goes through a process. So you see that it gets further and further. The further you go through, the more and more detail it gets.
Right.
All right, so here it's just saying that diagrams shouldn't resemble flowcharts, class diagrams, or call graphs. You see it's just saying that it should not resemble this.
Okay.
And so here is showing a context diagram of this particular castle service, and you see the actual boundary and whatnot, and then you see all the data flows going, all the flows that are going through this particular system. Because when you develop your bound, actually that's not it. This will be closer to more of your use cases and stuff like that. And so this is showing a level 1 diagram, very high level.
Mm-hmm.
So you see the entire system. Okay, I guess they don't show the whole thing. Actually, castle service is right here. So here you see castle service.
Okay.
It's a lower level. All right, so here it's talking about the process of identifying threats. So you have experts that can brainstorm. Usually you have, like I say, a security team, and maybe they've identified threats on a similar project, and those threats are documented. Also, there are websites that you can pull threats out as well. You have something called the Common Enumerations and Common Weaknesses Enumeration, CWE. MITRE, they're a defense contractor, and they put out a ton of different threats that are actually available.
Okay.
And I'll pull up a website to show some other items as well. And so here is showing various threats: spoofing, tampering, repudiation, information disclosure, denial of service, elevation of privilege, and then property that we want. It's just showing the associate property that is wanted. What I'm going to do is I'm going to share something else, and this is going to show you they're a defense contractor, and they. Okay, so let me do this. This is I see that this no. So I'm going to share this. All right, so this website that you see here, this is the information assurance support environment provided by the Defense Information Systems Agency, and they do a lot of stuff with cybersecurity.
Okay.
And so what you have here, when you scroll down, you can see tons of different items, and they have something called STIGs. These are security technical implementation guides.
Okay.
So if I bring this item here up, you can see various updates. So I can say, okay, you're building a product for, let's see, just go to the master list. And so here you can see a master list, and it has a ton of different stuff. Android, Apache servers, Apple iOS, BlackBerry, Cisco products, host-based security system, it's a Department of Defense product, device network management, remote device network management, ESXi, which is a VMware product, HPUX, yeah, IAVM, the CV, this is just mapping. But you have all these different items here that you can actually use. So when you're doing your threat analysis, you can say, all right, we're going to be using, maybe we're using McAfee or something like this, but you can use these items right here to test and to harden your actual device.
Okay.
Right. So this is a great tool, and I'll share this on the website, and you can see that like I said, there's a ton of stuff here. The other cool thing is I can say, all right, I'm going to click mobile devices. I'm building something for mobile devices. Okay, this one. And you can kind of see at least some guidelines of what some other organizations are actually doing, which is it's pretty neat. So you don't have to do everything from scratch.
Right.
The other item is the NIST. So this is what I was talking about earlier. This is from the National Institute of Standards and Technology, and this is their IT laboratory and their computer security division. It's a computer security resource center. Sounds very redundant, but their special pubs has a ton of different guidance for various security-related items. So supply chain. So maybe one of the risks is if you have this, say you're doing a full-fledged extensive project, and you're like, well, we're going to look at actually shipping this item out. So you can look at risks that are risks and threats that are actually associated with supply chain. If you look at the SP 800-161 draft.
Okay.
And so there's a ton of different stuff out there. I'll post this information so when Moon is doing the threat modeling and stuff, he can say, okay, oh, well, we can look at this. We're using this particular type of software, so these are the inherent threats that we have. And then OWASP. OWASP, they put out the top 10 threats.
Mm-hmm.
And so here you can see the 2013 top 10 list. Security misconfiguration, sensitive data exposure, cross-site request forgery, using components with known vulnerabilities. You click on this item here, and it brings all those items up. You see that?
Yeah. Wow.
Already there. Yeah?
Mm-hmm.
I feel like I'm doing a project for you. I think I need another master's degree. What do you think, Sophie? So, yeah, and this item is right there. It talks about the threat agents, the attack vendors, security weaknesses, technical impacts, business impacts. So everything is right there. How do I prevent? So, you have a particular risk that you identify, and you say, okay, well, how do I actually prevent this item? It says right here. And then even the thing that I like about it as well, it provides references. So you can look at various references that are associated with the particular risk.
Oh, cool.
So those items are provided, and you're able to go through them and use them to assist yourself.
Nice.
All right. So any other questions?
Not really that I can think of. Kind of trial and error is what we're doing.
Okay. Well, we will go through some more of these items. Actually, those are all just technical ones, so we can skip the rest of this presentation. So let's see. Let me stop sharing. All right. So if you have any issues in the meantime, reach out to me, and if you want to schedule a Google Hangouts for just your group, we can do that as well outside of class.
Okay.
So say if you're working on a project, we can bring up your project here. You can share your screen, and we can go through and see, okay, what are some of the items that you're having or issues, just to make sure everybody's going to be on track and complete the deadline for the course.
Okay. Sounds good.
All right. Pleasure talking with you. I'm glad that you're my only one here.
Yeah, brownie points, right?
Maybe I'll give you actual brownies, but not actual brownie points.
All right. Thanks.
All right. I'll see you. Bye.